Welcome to the breakout for the bachelor's and masters of science and software engineering. This will cover both programs. We'll probably primarily focus on bachelor's, but we will get to the masters at the end. I'll start by introducing myself. So I'm Jared Plum. I'm the Associate Dean and Director for Software Engineering here at WGU. I've been here for about a little over 2 years now. Before that, I was a chair of computer science at a different program. And before that, I was actually in industry. I come from the game industry, worked on a lot of big companies. I've worked at EA, I've worked at Microsoft, I've worked at Disney. So I bring a lot of perspective that's a little unique. I like to get students coding quicker. That's been a little bit of a change since I've gotten there, and kind of has to do with my professional experience about what can students really accomplish. So let's talk about what is software engineering. So we get a question a lot, especially in these kind of meetings of like, well, what's the difference between computer science and software engineering? And we'll talk about if this is right for you in a minute, but I kind of want to address the kind of that difference here and the fact of what is software engineering. Software engineering really is the full process it takes to get software out as a product. So it's not just programming, which I mean, computer science isn't just programming either, but it's not just the programming itself, it's the whole development cycle. It includes like testing the products, designing the products, everything that's associated with it. Computer science traditionally is a little bit more algorithmic driven, a little bit lower level. Not that they can't do this too, and they do a lot, but in software engineering, we really do focus specifically on the software itself. You can see here, we kind of have a little bit of the software engineering life cycles. There's many different types of life cycles that people follow. But in here, you can see that we have several different ideas of how that ends up applying, and we do explore those more in the program. So what are some of the common skills that we see within software engineering and specifically within our program? So you can see these common skills here on the left. These are a little bit more generic, a lot more soft skill. You just see generally the idea of communications. You can see troubleshooting and problem solving on that list. These are things that you basically do on a daily basis. On the other side, you can also see some of the hard skills that we have. You can see things as, in this maybe the slightly simpler realm of things like JavaScript, getting more complicated in Python, and then having either Java or C# depending on the track that you choose. We do cover, things like Amazon Web Services. We talk about agile methodologies. We talk about a lot of these topics that are very specific to software engineering. So why study software engineering? So a lot of you who are here, you've probably already decided that you're in software engineering, but there might be a little bit of a question mark of like, well, is this right or not? So first, like, why would you study this? So even in up and down economies, software engineering hiring is strong. There's a high demand for students who graduate from software engineering programs, and they pay a lot. Now, you always need to be careful with that. It pays a lot because this may not be the greatest field for you, if it's just pay is the ambition. And like I said, I think next slide, I think we'll get more there. But also, why would software engineering potentially be right for you? So basically, you like the degree of flexibility. You like being part of that solution. You like being on a team, and you like basically problem solving. These are really reasons to study software engineering. And probably first and foremost, you really like computers and you really like building software on them. Some of the top job profiles, this may not be a surprise to some of you, but maybe it is to others. Basically, we live in a world now where every single company does software engineering. So we do have the big companies you can see on here, like Apple and Google and Amazon and IBM, these ones that are traditionally associated with software engineering. But you can also see on here that, top employers include like United Health, JP Morgan Chase. Basically, software engineering has gotten into everything. And so everybody hires for it now. The title, generally, it's software engineering or software developer are generally the position that you get afterwards. But you can see here that there's a whole bunch of other names for what that specific position ends up being. So like I mentioned briefly a minute ago, is software engineering right for you as a student or, right for me? So what I like to say is that I never know if you're really a software engineer or not. Every now and then, maybe I meet somebody, I'm like, oh, this is definitely a software engineer. And I think maybe once or twice in my whole career have I ever met somebody who said, you're definitely not a software engineer. Typically, this is somebody who really just can't stand being inside. Their job is they love the idea of construction or something outside. Even I've known people who were software engineers who actually enjoyed construction and they still did really well. The easiest trick to really find out if you're a software engineer is to take a programming course. Once you've taken that first programming course, it really helps answer that question really quickly. But a lot of the characteristics that that this is potentially your field. We have some of the questions here. Are you interested in technology and programming? Are you analytical? But I think one of them that I've asked students over the years is I said, so when you were taking your math classes in high school or maybe in college, did you enjoy story problems? And because programming is like amplified story problems. It's like story problems on top of story problems on top of story problems. And you don't always solve it with actual math itself like you did with those story problems, but you do solve it with coding itself. You're basically creating formulas, you're creating applications and such just to solve that problem. Actually, I want to go back to this here. Did we establish, Matt, if they can hear you? Okay. Well, maybe I won't turn it over just to be safe. I was going to turn over maybe a question to you here, but maybe we'll just move forward then. Sound like plan? Okay. So bachelor's in AI. The are we talking computer science or are we talking the master's level? Oh, okay. I think the question has to do with the bridge. Let's come. If I don't answer this question, let's come back to it. But let's get into the bridge because that might clarify this question. So. So let's talk about the Bachelor's of Software Engineering real quick, and then, like I said, we'll come back to what's called the bridge, which might be what they're talking about is the Bachelor's in AI, which is not quite how it works, but we'll discuss that. So we built the software engineering with input from industry. We do follow a lot of academic processes, so that it's not a program that's foreign to other institutions, but we really take the advice of industry and people who are hiring grads a lot more serious than we do sometimes the academic process. And so the software engineering program itself has a solid foundation in some of these skills that we got from industry. And in particular, scripting and programming, web development, we use these at our foundational level. So we still teach programming, and then we become more application driven later in the program. But early in the program, we do really focus a little bit of the skills that are not quite as difficult as the later portions. But we do eventually get into things like mobile application development and just general software development also in regards to that line. The program itself is 119 CUs. So for those of you who aren't familiar, it's kind of similar to a semester credit hour. We do have three third-party certifications in it that you can see here on the right within Project Plus, AWS Certified Cloud Practitioner, and the IDLE Foundation certification, which is a project management side of things. The a good chunk of our students do finish it in about 3.5 years. I do want to say that the program is highly technical, so we do have students who blow through it right away, but that's not really typical. So for a lot of you who are hoping to get done with it in like 1 term or 2 terms, it does happen, but we have 7,000-8,000 students, and we see it maybe once in every 4,000 or 5,000 students. So it's a very rare thing. But most students do finish it under that 4-year mark, which is what we want. We really want that to happen. We really help try to guide students in there. We also, depending on the track you do, we do have 2 WGU certificates in here, back end and front end. Back end is only in the Java track, not in the C# track. And that brings up the other thing is we do have 2 tracks in software engineering. We have the default is Java, but you can request anytime before term 6 to swap to the C# track. Basically, what you get is a chunk of courses that are in Java or in C#, depending on what program you're in, and a bit of a focus difference in those. So they're not really kind of a one-to-one swap because of the way that both of these languages handle. Mostly one becomes a little bit more Microsoft focused, while one becomes a little bit more Oracle focused. In here, you can see a few courses that we have and what ends up being used in there. Early in the program, we do teach students how to use Git, and we do utilize Git numerous times in numerous courses. And this is really kind of industry standard. For those of you who are familiar, we typically use GitLab. We do give some exposure to GitHub, but generally we do most of our work within GitLab itself because we've created some cool pipelines with them to make it more fun. You can see other Docker, for those of you who are familiar with Docker. Spring and Angular are Java technologies that we do expose students to. But you can see here that's typically in the Java track, not within the C# track. Okay, so this might get back to that question we had earlier. Let's talk a little bit about the accelerated bachelor's degree or bridge program, as it's called a lot. So we do have an option for a student to enter into the program and enter into a master's program. How this works is, okay, yeah. So how this works is that the student, what they'll do is they'll get some of the master's courses actually in their bachelor's degree, helping reduce the overall time it takes for them to complete the master's degree. Where maybe some of that confusion's at with this is that when you do go into the bachelor's degree in the bridge, you're also accepted into the master's program. However, you do finish the bridge first before you go into the master's program. So for instance, if we'll talk more about specializations in a minute in that, but if you do go into like AI engineering as an example, AI engineering is not in the bachelor's, it's actually in the master's. So you finish the bachelor's degree first, and then you go into the AI engineering bachelor's degree. A couple of quick notes on this. There are 4 courses from the master's degree that are in the accelerated bachelor's degree. And then there are 3 tracks in the master's degree to choose from: AI engineering, domain-driven design, and DevOps engineering. And we'll discuss it more in a minute here. And the kind of default timeline that we have mapped out for this is it takes about 5.5 years for you to do both programs and graduate. So first you will actually graduate with your bachelor's degree, and then you'll graduate with your master's degree, but you'll do both of them in a shortened time period. Okay, so for the bridge, though, one thing to comment is that it is only the Java track. We do not have the C# track part of that. Also, for those of you who really wanted the AWS certification, that is also not in the bridge because that's actually one of the courses that's replaced with a master's level course. So, but you do still earn the front end and back end certificates along the way. So the benefits of the accelerated program is you do finish quicker than you would otherwise, because you do reduce 4 courses that you take as a whole. And overall, if you follow the path, it is cheaper to do it this way than it is to get the bachelor's degree and then get the master's degree. However, the challenge is it is more difficult. Sometimes students get into that first master's level course and they think, oh yeah, I'm good, I know what I'm doing and everything, and then suddenly they hit a graduate level course and they were like, oh wow, these are way harder. So they are harder courses with a higher expectation. And there is a knowledge gap risk, which basically means that what happens when you go into an accelerated course that is a master's course driven in there is an expectation that you do self-study to get up to speed with what you need to do. This is a general concept of graduate programs as a whole. They don't necessarily hold your hand quite the same as a bachelor's degree. And so it can be a challenge if you go in there and you potentially don't have that knowledge. But as you can see in here, this is just kind of a general layout of how that progress works from going from the bachelor's. Basically, you take the core normal bachelor's courses that are part of software engineering, and then you take some of the accelerated courses mixed with it. You graduate with that software engineering bachelor's degree, then you move on to the master's degree, and then basically some of your courses are already satisfied, and then you continue forward. And then the very end of the master's degree is when you actually hit those specializations. Okay, so let's talk about the master's degree a little bit here. So the master's degree, it is relatively new. So we are still getting our feet wet. For those of you who have followed us, we have students who have already finished and graduated. So that's actually awesome too. So it's super experienced, even though it's only been out for a short period of time. But we've been excited to build this and offer it. So the program itself has 10 total courses. 7 of them are in any of the concentrations, and then there are 3 separate concentrations. So you can see here some of the courses. We really tried to jump into the software engineering life cycle, but at a graduate level, where we are really diving students into what it means to really build software modernly. We do have kind of an easy step in there for people who have closely associated degrees or have taken a programming course. Although the preference is that you have a bachelor's degree before you go into this in something like software engineering or computer science, we do recognize that with graduate degrees, that's not always the case. And so we do start with this real life applications of data structures, which is an actual data structures course, but it also is kind of how things are more applied when it comes to the data structures concepts. And so basically, you need to have an object-oriented programming level of skill before you hit that course. So one of our concentrations, probably our most popular one right now, is AI engineering. It has it basically was built to what AI engineering really is it's not really building the specific algorithms. It's good to have a general knowledge of that, but it's really saying, here are the AI libraries that exist out there. How do I build a product that uses it? Or we have a product, how do we integrate AI solutions into it? And so it's really about using those tools and those technologies to build basically modern day, because as everybody has seen, everything is starting to use AI. Domain-driven design, our next concentration. It's for those of you who are familiar with the subject, it's kind of our software architecture, but it does really specifically focus on a concept within software engineering called domain-driven design, which is kind of the idea of how do you build small pieces of an application and then reuse those pieces, and how do you structure an application to really be productive, especially environments where we have lots and lots of people working on different pieces of code. And then our last concentration we have is DevOps Engineering. This really kind of focuses with the aspect of how does products get released themselves? How are they maintained while they're being worked on? What is the process that we use to keep building them, making sure they're not breaking? And yeah, this is actually a pretty exciting area. It's an area that software engineering has really started expanding upon, especially as the paradigms of what is software has changed. So it's a pretty cool program too. So let's talk about admission requirements here for a minute for the master's level. The easiest way, like I said, is if you have a bachelor's degree in something like software engineering, computer science, or any of these closely associated fields, you have no problem. You can get into the program. If you don't have that, because some of you, I think, are working a bachelor's, you're not sure what you're doing. For those of you who don't have that, if you do have an object-oriented programming course from somewhere else, you can also use that. You still have to have a bachelor's degree, but you can also have taken an object-oriented programming course. We also do offer through our WGU Academy an opportunity to take a course that is qualified for this. And what is nice about that is if you do it, you pay for the course, and then we basically reimburse that into your tuition itself. So for those people who are like, oh, I kind of want to try this and everything, it's kind of our way of allowing that at a low risk way. We have had students who've entered the program with our option 3, which is 2 years of industry experience as a programmer. That's not super hard to do, but you do have to have some documentation that they end up wanting you to provide for it. And then also, if you do have your current active certifications in several of these certifications that are a little bit harder to maintain and stuff, we think that really shows that you know how to code, and so we're not too concerned about it. So if you do have one of these, we'll also accept you. Okay. Yep. Let me, yeah, let me stop sharing that and come in here to kind of come in here and start answering some questions. So, okay, so Andy has yes, the bridge. I'm honestly trying to see if the program is enrolled. It will provide similar opportunities job wise. Yes. So the bridge is the same as the bachelor's degree of software engineering. It is the same degree. It's just it's an accelerated version with master's courses. So it's actually slightly harder than a normal bachelor's, but the degree itself that you do get is a bachelor's of software engineering. And then Andrew's comment, I'm set to start this program in October with the ultimate goal of becoming a software engineering manager. Is this the best program for that goal? Um, I'm I'm not sure what program that is, but I would say from the concentrations, if I had to speak to that more specifically, the DevOps engineering is probably the best one if the goal is to become a manager. The world of software engineering management is a little odd. I was reading an interesting article by the CEO of JP Morgan Chase recently, where he was talking about coding skills. And he said that with AI, everybody's getting concerned about coding skills and everything. And he said, no, we need the coders and this isn't going to change anything. But he also said we need the product managers. And I thought that was really interesting, is he said a lot of people aren't looking at that. And so some companies, like if we look at like a Google as an example, you really have to have a really solid engineering background and you have to have a lot of experience within code to be able to get to those manager roles, because that's how they work. But a lot of companies don't work that way. And the fact that once you have a degree within that field, they do hire in there. But it kind of depends. There's kind of this idea of product management, and then there's this idea of like lead programmer kind of concepts. Lead programmer still requires a lot of that technical skill. So great questions, though. Yes. Okay. So Meredith's question in here. I noticed a lot of associate level software engineering jobs require proficiency in JavaScript and React. Will these be learned in the degree program? And if not, how should I acquire them? So yes. So React is a little bit tricky. We internally have a huge debate back and forth between React and Angular. Had I built this program from the ground up, I probably would have gone with React over Angular. That being said, the program in JavaScript mostly, but there is some discussions of React, and I think a little bit. And in the capstone, there's also opportunities for React if you want. We actually started looking at switching to React, and then Angular got an uptick again. So it just kind of depends. They're very learn. But the front end certificate, very specifically, is very much focused on that Angular line, that JavaScript line, and everything like that. So yes, it's actually a strong part of the early program. Okay, let's get this question. How do we pass courses in the masters? Do we complete assignments? When can we retake it? So this is part of the WGE model. We have different kinds of assessments. There's objective assessments, which are usually like, for lack of a better term, usually like multiple choice exams. We also have a thing called performance assessments, which is like a project you turn in, a paper you write, something that has a little bit more back and forth. Currently, I do want to say this, I want to emphasize it's currently within our master's degree, all of the assignments are performance assessments. They require you typically to turn in some code, some evaluations, some papers, and some combination. They're usually multi-part. They're not exactly small, but but a lot of students do get through them quick, especially if they already know a lot of the material. I say the reason I say currently, though, is that as you're going through this program, unless you're planning to finish it within one term, things do change over time, and we do go back and forth between objective assessments and performance assessments. So generally in software engineering, I have a preference towards performance assessments because I like somebody to actually code, to actually turn in some level of material. So. Oh, I want to talk to this question. Sorry, I got distracted by one here. What are your thoughts on how AI has impacted junior development roles? Like AI removed the need for most junior dev programmers. Okay, I will say that companies traditionally have masked layoffs with excuses. I will say that right now, what we're seeing in the field is an excuse that we're replacing the jobs with AI. The challenge is for any of you who have used AI to try to code something, for those of you who know how to code, it's not super great. It can solve problems and it can help with brainstorming, but it can't solve any of the hard problems. And so, but at the junior level, it is interesting because junior level programmers are a lot of times solving easy problems that maybe AI can solve. But in the scope of software engineering is not about just the code. It's about how do we piece the pieces of code together to build a product. Sometimes there's not even code in various parts of a product that we build. And so I think in the junior level, even though companies have slowed some hiring as of late and everything, it will pick back up and it won't be really a problem. There was a really good interview with the IBM CEO where he actually really doubled down on that, and he actually stated that he thought it was kind of silly that people that any software company would say that that AI would. It's really good at solving simple problems that everybody can do, but it can't solve any of the problems that are hard. And that's really what software engineering is solving hard problems day in, day out. If everybody could already do it, it would already have been done, right? Everybody's trying to build something new and something different. So, yeah. Yeah, yeah. Okay. I like Christopher, your comment is great. So as somebody who's worked at big companies, I will say that a good chunk of getting into those big companies is luck. I started off my career at Microsoft, and I will say it was luck. Basically, I just happened to run into the right people at the right time with the right skills. But what I would say that is probably a really big one is that it's really about what you've done on your own. When you're going through your courses, we're going to give you content, we're going to teach you stuff, but it's about you saying, oh, I've learned how to do something. Now here's what I can go do. Go create yourself a GitLab or GitHub repository and start creating projects. Go get involved in open source, because then as soon as you graduate, you're like, hey, I just graduated with a bachelor's degree and here's what I've built. I In the past, I've seen students, for instance, who built their own mobile application that was outside the scope of what they did while they were doing it, just to see what it was like, and it landed them a job. Now, at the big companies, to get into those jobs, not only do you need to do that, but you need to be the best of the best. You need to really, really dive in. Data structures probably being a big topic, really diving into the data structures concepts and really understanding pretty much everything in that realm, and then really just getting lucky enough to land in the position. Yeah, yeah. And then I guess adding to that comment from, I have like less than a minute here, but adding to that comment from Elaine's comment here, um, internships are a weird bag in this field. Usually, you're better off just getting a junior level job. Internships are becoming more common, but they aren't crazy common either. And so I think that they're kind of more like scholarship driven. So the real trick is just get a position. Once you get a position, 2 years later, go get another position. And that's kind of how the field really works. Is once you get that experience, it becomes a lot easier to get another job. I do want to, I have 20 seconds to comment on James' comment about evaporating jobs in 2024. There were a lot of layoffs, but there also still are a record number of openings. So I do want to kind of comment that, this field is impacted very heavily by, news and what's going on, but it's a really solid field. So I look forward to seeing everybody around, and thanks everyone.